3. So we are at brain gym number 3. The first one, 6,200,024. Next one, 227 times 6 times 100. 227 times 6. 7 times 6 is 42. We group 12 by 2 times 6 is 12. 12 plus 4, 16. 1,362 times 100. So I add the hundreds at the back, multiplying, so it becomes 136,200. Next one, do 4 times 5 first, 20 plus 30 divided by 6. Do 30 divided by 6 next, 20 plus 5, answer 25. Okay, next one. What is half in decimal? The answer is 0.5. What is 0.25 in fraction? The answer is 1/14. Or 25 out of 100. Three correct, 1 stamp. 5 correct, 2 stamps. Please mark out on your handbook now. May I ask, question number 1, who got correct? On 34. We need to 34. Okay. All right, who got question 2 correct? Question 3. Question 4. Question 5. Okay, who got question 4 wrong? Oh, careless mistake. Who got question 5 wrong? Okay. Okay, can. Okay, have you marked out your handbook already? Now, flipping on to the next page. Okay. Flipping on to the next page. Next page, I'm going to talk about a little bit about the idea about fractions and decimals before we go back to the word problem question that we were at. Okay, ready? Now, so just now, the last question was, what is half in decimal and what is 0.25 in fraction? So these two involves a bit of conversion. Okay? Quickly, please. Now, so I'm gonna come here again, and I'm going to do a bit of drawing here. So this is 15th February. And I'm going to talk a little bit about fractions, decimals, and whole numbers. So exactly how these three are related. Okay, yeah, they're all made up of numerals, digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are made up of digits. And then the thing about, if I were to imagine I draw a number line out, you familiar with number lines? Okay. Not so much, then take a ruler and let's say, for example, we draw a simple number line like here. It's a line. And let's say I put this is 0, like nothing, 0 is nothing. I put like one finger here. Are you okay? Oh wait. You're not so stressed. No need to stress. I put one finger, two fingers big. Every time we talk about fingers basic. New paragraph. Amazing. I mark up two fingers and then make the one. Do the same. Two. Do the same. Three. Do the same. Four. Is this okay? Uh, 0, 1, 2, 3, 4 sounds quite okay, right? Are they big numbers? Not so much. So it was Cheryl yesterday birthday yesterday. Do you had a cake or something? What was the flavor of the cake? Wow, salted caramel. Was it round? Like a circle? Oh wow, salted caramel cake. How many people were sharing the cake? Five. Huh? Five people were sharing the cake. Yummy. I wish it was six, like six is number B. Right. Yeah, yes. You'll wear the thick charge shirt for the whole day tomorrow, including for P. Is that P tomorrow? No. But you can just wear it for P. It's quite comfortable. Yeah, you can wear it for CCA also. Thick charge day. I mean, if you have CCA, then you wear your CCA jersey after that. Okay? Alright. Is it okay? 0, 1, 2, 3, 4. Is it not very difficult, right? So I'm gonna imagine I have Cheryl's. Oh, 0, 0 is nothing, no cake at all. Cheryl's salted caramel cake. Yum yum. Yum 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 yum. And what's two? Two will be two pieces. Two cakes to be exact, actually, right? Two cakes, right? Two whole cakes. If it's three, it will be three cakes, three cakes. Three whole cakes. Something like that, right? Three whole cakes. So when I asked Cheryl about sharing the cakes out, right? So the one cake here is one cake was cut into 5 parts. Yes? Five is a bit hard to draw. Make a point here. 1, 2, 3, 4, 5. Try your best. Not to try your best to draw equal parts. A bit hard to draw equal parts. You did it? So you like one cake. You did it? Oh, nice, very nice, very nice. So one cake. We join it with the numberless equation idea. Is that Cheryl's salted caramel cake, one whole cake, was shared by 5 people. Very nice. Was shared by 5 people, like divided by 5 people eating the cake. What does the fraction looks like? Each person will get just one slice, right? Right? So it looks a bit bigger than like that, something like that. So it will be 1/5. Each person gets one slice. 1/5 of a cake. Does it make sense? Does it make sense? Yes? Yes? Now, right. Can you find the fifth on the number line? The 1/5? No. So this is one whole cake, right? Where should I place this on the number line? And here? Here? Here. In the middle. The middle. Closer to the zero. Why is it closer to the zero? If it's in the middle, what the size would that be? Half a cake. Yeah, very good, huh? You got that point. So I should be like this horizontal number line. I should be trying my best to cut it into 5 parts 2. Is it correct to say that? So if I was to label this number line, so the 1/5 is here, and this would be a piece of the cake. Does it make sense? You don't get the whole cake. You visited Cheryl's house and you're celebrating birthday, and you don't get the whole cake. You only get a slice of the cake. Now, a slice of the cake, because there are 5 people sharing, a slice is a fifth. It looks something like that. Does it make sense? So do you see where this fraction is? Yes? So do you know what 2/5 look like? So 2/5 will be 2 of the pieces. So 2/5 will be, just get another one and you got 2 pieces. Each piece is a fifth. Make sense? Right? Okay. So 2/5 is like 2 pieces of the cake. Cheryl Mummy. There's 2 pieces of the cake. But anyway, it's not going to be the whole cake. Agree? I'm writing this. You're using your calculator to calculate what? What's your book? You have the table, right? Don't write on your lap. Your lap doesn't look like a table. Right. Does it make sense? Now, imagine this is money. Okay? I'm going to draw the money here. Let's say this is $1. $1, right? Now, what does this mean? You have $1 and then $1, right? Or you can draw a $2 note. That's also fine. Make sense? Correct? Now, what do you think 1/5 will be? Like $1, right? $1, right? Imagine $1, $1, right? And I cut it into 5 parts. What do you think 1/5 will be? 20 cents. 20 cents? 20 cents? So $1 divided by 5 people. I share out the $1. Each person should get 20 cents. Does it make sense? You can't see, oh sorry. Does it make sense? $1 divided by 5 people, each person get 20 cents. Yes? Yes? Correct? So 20 cents, do you know what the right 20 cents in dollars? Is 0.20. Oh, you can write the 20C in the back, right? But if you have the dollar sign, you don't write the C in the back because this decimal point stands for cents already. Now, does it make sense to you? Can you see where it is going? Now, so we are saying that 1/5 1/5 here can be regarded as 20 cents, 0.2. 1/5 here. So I can, in other words, I can say here, 1/5 of a dollar gives me 20 cents. Does it make sense? Is it okay? Because by now most of us are able to say, what's half a dollar? Half of a dollar is 50 cents, 0.5. So you see the fraction and the decimal, they are different, made of different numerals and different digits. But can you understand how they are equivalent? Equivalent? Yes? Yes? So half of a dollar is 50 cents. Everybody knows that, right? Can you find 50 cents here on the number line? So just now, Amara already said, if it's half here, this is half, it will be 50 cents, 0.5. But if I put this back to the cake, what does the cake look like? Huh? Half a cake. Very good. Okay, so this is where it is. Half a cake. Now on the same number line here, can you find where is $1.50? $1.50. In the middle, in between $1 and $2. Is it okay? So in between here will be $1.50. Between $1 and $2, $1.50. Sorry? Very good. I like exactly what Skylar said. So at $1.50, it's like the same as saying I have one whole of Cheryl's cake and then another half. So what would this fraction be? And the cake's not the $1, unless it's like a mini cake, like the pin size cake, a cake for my hamster. Now, so in fractions, what will that be? In fraction, what will this be? 1 whole and half. Does this make sense? 1.5. That's the decimal. $1.50, like Skylar said, is about like something like one whole cake and then another half. Can you understand what this is going? One half, 1.5. Now, from this number line, look, 0 is nothing, nothing is 0 means simply nothing. 1 is a whole cake, a whole dollar. 2 is 2 whole cakes, $2. 3 is 3 whole cakes, $3. What are all these things in between? Are they whole numbers? They are not whole numbers. They don't make up wholes. They are what we call decimals or fractions. So what exactly are fractions and decimals? Fractions and decimals are like found in between whole numbers. Well, they can be made up of all numbers in the world, but placed at different. They mean different things when placed differently. Okay, so far so good. Makes sense or not? Anybody don't understand anything here? Right, as I was saying. So The main idea why I draw this for you is to help and bring out the idea about Cheryl's stories of cakes and about money, is help you to see where fractions and decimals are and where are they in life actually. They are like in between whole numbers. So I can have 6,200,034 dollars. At the same time, I can have 6,200,034 dollars and 50 cents. You know what I'm saying? You can still have decimals after that and fractions after that. I can have 600 cakes to celebrate Sarah's birthday. And I cut them all out to celebrate with all students of Lakeside Primary School. And do you think there'll be enough cakes to go around? Still not enough. Because we have 1,300 students. To share out 600 cakes, still not enough to share. End up the answer will still be a fraction if we share out things. Now, I'm going to go back to the question that you said Mr. Shah went through and he put you some answers, which was like this. So I'm on question 30, on page 38, question 4 now. I'm going to take out my calculator and talk about how decimals and fractions in these two questions coming up. Okay, so yesterday we were here. We were talking about how there's this container with juice, 7 liters, and they are poured into bottles. So the idea is you have all the juice, all the juice divided by the amount of juice in one bottle. So in one full bottle is 65 milliliters. So I'm going to pour one bottle until I see how many bottles can I fill up. So using the calculator, I press 7,000 divided by 65. It gives me a weird fraction. And if I change to a decimal, it looks like this. 107.6293 ... Okay? Now, I could change this to a mixed number by pressing, oops, sorry. You have to press the shift function. Can you see the shift function? I press the shift and this. Yeah, it's here. So you press the second function button and you press this. This is the mixed number. You press the second function, you press this together. You try? Yeah. 7,000. So I'm doing 7,000 divided by 65. I'll get this weird, what we call improper fraction. Press 7,000 divided by 65. 7,000 is all the juice. Divided by 65, there's a amount of juice in one bottle. I divide already, I get this weird improper fraction. Now, if I switch it to a decimal, I press this, I'll see a decimal like that, just like yours. Then I'll press shift. You press second function, and this function. X. Okay. I will have to figure out. Stella, I'll help you figure out later, okay? It's a different calculator. I need to figure out your calculator first. But I'll go through this, the one that everybody has first. Everybody can see this, right? So you get a decimal. I get back to the fraction, I can press shift and I get a mixed number. So most of you say you get, Mr. Shah tell you this is the answer, right? Something like that? Does it look like that? Yeah. Okay. Now, then we come back to the question here. The question asks, how many bottles containing 65 milliliters? Okay. That means 4 bottles. Now, let's take this number. These are the whole number. Can you see this is the whole number? And just now we discussed. So this here, this part is the whole number part. And this is the decimal part. This is the whole number part. This is the fraction part. So just like the cakes just now, I'm going to look at this 107 and ignore the fraction first. This means A. The number of bottles that are full, 65 milliliters, is actually 107. It's 107 bottles. 930, what does it mean? It actually means, for some of us, we know, oh, that's decimal. That's something like a remainder. If you were to do long division for this, no problem, you will see the remainder happening. However, Stella, can you do that later? I'm writing this down first. I can help you to sort it out later. The scissors is on the ground. I'll take this whole number and I go to B. Now, so actually it's 107 bottles. So if I take 107 bottles, I multiply by 65 milliliter each. What would this answer be? 107 multiplied by 65 in my calculator. It gives me 6955 milliliters. Now, actually, what does this mean? This is the amount of fruit juice that went into the bottles. Can you understand what I'm saying? So, to find out the juice that's left over, that didn't get into the bottles, what do I do? Yes, I'll take the actual amount of water or fruit juice. I minus what's used. What's actually used. I will get the leftover remainder. And that is 7,000 milliliters minus 6,955 milliliters. The answer will be, use your calculator, 45 milliliters. So, the answer here is 45. 45 milliliters is the leftover juice that didn't get into the bottle. Now, imagine I'm going to pour these 45 milliliters into a bottle. Do you think it will be full? The bottle is 65 milliliters, right? If I pour this 45 left over into the 65, do you think it will be a full bottle? No, it won't be, because it's not enough to fill the bottle. That's why it's only if you only fill part of the bottle. You understand? Do you understand what I'm saying? Can you understand or not? It's a little bit more, it's a little bit difficult to understand now. So here, 45, I pour the juice, then I got some leftover. Some leftover in the container here. Here. Some leftover. Then I try to pour into like one more bottle. Actually, not enough. The bottle only fills, so altogether there's 107 full bottles. Then I try to fill another one. Here is 65 supposedly, but not enough. I only fill up to 45. So that only half of the bottle is filled. Can you now try 45 divided by 65? What do you get? What is that? Do you get the fraction? Do you see where the fraction is now? You see where the fraction is now? You can try to, Skylar, you can try to put 45 out of 65. You get the same thing? Do you see the remainder 913 out here? So 913 was a part of a bottle. Was this one? This is where 913 is. It wasn't a full bottle. So in my answer A, I should not put 9 over 13 here. Do you understand? Because it's not a bottle. It's only part of a bottle tube. Can you understand? This question is quite popular during exams. Okay. Now we move on to a similar question. Page 40, question 7. Now I wrote this as DIY, but I'm going to go through it now. Because this one is also a bit, it's similar to just now question, but not exactly the same. Yes. Now, this one, not really the same, but very similar. Okay, so here, the story goes as, did Mr. Shah go through this question? Think so, not sure. Okay, now, so let's do what we did for the past 2 days. I said that we're supposed to do the annotation. Then after that, we write down the numberless situation. So in the just now story is that I am going to fill the container, fill the bottles. Just now story is one bottle is 65 milliliters. Don't know how many bottles I'm going to use. Okay, so the fruit juice go into the bottles. Don't know how many bottles going to use. This one is a bit different. This one, the beans go into bags, but you already know how many bags. It's 15 bags. So in other words, I have this big container of a lot of beans, jelly beans. I'm going to put these beans into, I already know 15 bags. One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I already know there are 15 bags. So what I'm going to do is I'm going to put one inside, 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 put one inside. Maria, can you turn off the first row of lights? Thank you. And then I'm going to put one inside. Now, how many have I put already? One in each bag, right? How many beans have I used up? 15. And then I will continue and put and put and put, put and put and put, put and put and. This is like equal sharing. So I already know how many bags of jelly beans. So I can just go with all the beans divide by the number of bags. And that should give me number of beans in each bag. Now, so, and I use the calculator to calculate this. 4,689 divided by 15, it actually gives me a weird answer too. 4,689 divided by 15. It gives me this fraction. It tells me that something is not right. It's either I'm like not going to have the bags filled properly, I'm going to run out of some beans, or have some extra beans. Basically, the number of beans in each bag is not going to be the same. If I change this to a decimal, it's 312.6. 312.6. But I can't say I have pointed the bean. You know what I'm saying? I chop the bean up into 10 parts and then it's not possible, right? So probably, hold on. Probably I'm gonna just leave out some beans. Or like here says, leave out some beans. Now, let's ignore the decimal place first and look at this whole number. So 312 are the very sure whole beans in the bag. They are definitely, you're not going to cut up any beans. You're going to get these whole beans in bags. So actually, how many beans went into bags? If I take the 312 beans, multiply by the 15 bags, I should get 312 times 15, 4,680. What does the 4,680 mean? Yes, the actual beans that we use. Beans that went into bags. 4,680 beans went into bags. So what's the leftover? All beans minus the use will give me the leftover. So 9, yes, that's correct answer. 4,689 minus 4,680 gives me 9. So 9 is the left. Then what is 0.6? It's clearly it's not the correct answer, right? It's not. I subtract it out, I can tell it's not. So by right, if I look at it, if I use long division to do this, I should actually get 312 with a remainder of 9. But that's not what I got with my calculator. My calculator give me 0.6. And 6 is not the answer. Yes. Let's see what. You want to move over there? You can, just move. You can be in front of me, yeah. Just bring your things over. Ethan is not writing anything, so Ethan can move away and you can take the seat. Or Marian, you can sit at Lance's place. Can you hear? Oh, also can. Is this okay? Now, then what is 0.6? Ayuh. Okay, so let's see what it means. I've until 4,680, right? It means when I stop here at the last bin that I view, each bin inside should be 312, 312, 312, 312, 312, 312, 312, 312, 312, and blah 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 blah. Until the last bin is 4,680. Then imagine I'm going to take the remainder 9 and I put inside. One more, one more, one more, one more, one more. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I put in 9. So the 6 becomes 6 and 6. 6 bags don't have one more. You know what I mean? Because you ran out of that. It's 6 short. Can you use 9 and then divide by the 15 bags now? Or do you get the answer? 9 divided by 15. You got the 9, right? Remainder. Divide by, so I share it out. Not enough. So 9 divided by 15, what's the answer? Press your calculator. Press your calculator. 9 divided by 15. What's the answer? 0.6. Can you see where's the 0.6 now? So the decimal means, hey, actually some of the bags are going to get something extra, which is the 9. So 9 out of 15 bags are going to get extra if that happens. Now this is a little bit challenging. And when you go primary 6, you'll beat this kind of question again. And when you are doing fractions, you get more complicated. But hopefully by then you'll be more confident. Now, the key thing to ask yourself when you are doing this question in exams, the quite a popular question in exams, is to ask yourself exactly how many whole bottles were filled or exactly how many whole bins were used. Then you have to do the subtraction. Is it okay? Can? Okay. Can. Then we move on to a slightly less stressful question. The rest I put here, DIY here, this is on YouTube already. So I will not be going through this. This is on YouTube already, I will not be going through this. This is also on YouTube already, I will not be going through this. So as this one. You go figure out which questions are already on YouTube. Those kind of questions I will not be explaining in class. As well as the last two, all the way page 44, page 45, and 46. These questions are already on YouTube. I will not be explaining in class. We will be moving on to the next chapter of fractions. And what time my lesson is supposed to end? 11:10. Okay. So still have time, very good. Okay, so the rest of the questions, thank you. So the rest of questions from page 41 to 46. Most of the questions are on the channel already. I will not be going through in class. Okay, tomorrow I will start on fractions proper. Today, the last question I'll go through is Mr. Lee's nephew. Page 42, question 3. 10:55. Actually, I think I had enough. I'll leave you to do it. Okay? You try it on your own. Tomorrow, I'll collect this word problem set. Okay? The whole thing. The rest of the questions, 4 to 8 are all on YouTube already. Huh? Sorry? Yes, do the whole worksheet. Is tomorrow too tight? How about over the weekend? Can you spend your weekend? Some of you already finished the thing. Yeah. Some of you already finished. Wait. Later I collect. Later. Some of you already finished. Can I know who haven't finished until page 8? Sorry, page 46. Oh, wait, let me finish the last sentence. May I know who have not finished until the last question on page 46, question 8? Okay, you can check on the channel, okay? Who's finished? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. For the rest of you, it seems like it's still quite a bit to handle. So those who are ready, you can handle it later. Right now, for the last 10 minutes, we will play play the game on iPad. All right. So for those of you who are ready to hand in, you come to me first. Those of you who are not ready to hand in, put the worksheet inside your bag. Take the iPad. Yeah, you need to finish the rest. Let me look at this.